Hello guys, in this video we're going to be going over lab number 9, pairs of ones, using Boolean shifting and jump instructions. Sometimes a set of data has an extra bit built into the code for error detection or and correction purposes. However, to use the information there must be some kind of program to read the code and then alert something to check it for errors. There are many ways to correct the errors, but to initiate the process, there necessitates something to give the information. One such program could detect pairs of ones in binary data. Okay? So pretty much everything you guys have learned from beginning till now, is pretty much different ways to manipulate data. Now, to create such a program, it is important to first fundamentally understand what it will require to detect the pair and then figure out how a counter could be set up to keep a tally of the detected pairs. The answer is to isolate each pair of bits, read them, and then keep a counter for every time both bits are high. And that will be the help of the shift and left instruction and your carry flag. So in this case, for example, the first one, what they're going to do, we're going to be shifting to the left one by one, and every time it hits a 1, your carry flag is going to change. And we're going to be counting pretty much when is the carry flag changing. Alright, so for this example, this one has 1 pair, has 2 pairs, and 3 pairs of 1. Okay? So we count how many pairs of 1 we have. And of course, C and D don't have any, and F has 15. Okay? Alright, so it's going to go, we shift to the left, and we're going to count bit by bit and binary when it changes from 0 to 1. And then it changes, and then we're going to see when it's going to stay as 1, and then changes back to the other number, the carry flag, I'm sorry. Yes, and then we changes to 0, the carry flag, not the binary, which to be honest means almost the same thing. Oh, the effect is the same thing, sorry. The effect is almost the same thing. Okay, so let's go ahead to the code now. Now before I forget, please like my video, comment below, share it and subscribe. And don't forget to read the description below for more information about the video, the timestamps, and how to support me. Also, be sure you guys read the lab instructions, okay? I'm not going to go through the whole thing. I'm just showing you guys the important stuff here. Okay? Here's the flow chart to help you guys with the programming. And here's the program. So let's go ahead to Visual Studios. Minimize this. Okay. Here in Visual Studio, we're going to go ahead and click Create Project. Template here. I'm going to go ahead and just click here. Next. Again, don't make it too dull and avoid spaces. We're going to do Lab 9 Program 1. Okay, keep it on check. Create. Open here, open it. Okay. Here's our template, and we're gonna just go ahead and again, do not copy and paste. Just go ahead and type it down, okay? Okay, now that my code has been written, let's go ahead and debug this. Be sure you guys have your breaker right here next to the move AX, X. Be sure also that here the debug is a x86. Let's go ahead and do build solution. Check that everything's good down here. Debug, start debugging. The flags, if you don't have them, do a right click right here and select flags. The watch one, if you don't have it, you will go to debug Windows watch 1 and type in the registers. Like for example, EAX, enter. Okay, let me go delete that. I don't need both of them. Okay, let's click the tab registers. As you guys can see, everything it starts at 0. Once we hit step over here, we're going to be moving the value of X to AX. X in this case represent, let's go up here, and hexadecimal 38C 0. In binary, if you put your mouse on top of it, it shows 14,528. Okay, so let's go ahead and do step right here. So the value of X got moved to register EAX, as you guys can see here. If I click watch 1, I'm gonna see the value right here, 14,528 and decimal. Okay, now let's go back to registers. The next step is going to be shift left by 1 space or 1 bit. This will add a 0 at the least significant bit. Okay, and also by doing that, it's the same as doing 2 times AX. So from the previous one of the previous labs, I think one of the first labs, we were doing multiplication by 2, and to multiply by 2, we just shift to the left. If you shift to the left by 1 and multiply by 2. Okay, so let's go ahead and do that. Okay, so you got shift to the left. By shifting to the left, the value of AX does change and just to this value. Okay. However, as you guys can see here, your carry flag, the carry flag, I think I mentioned this in one of the previous videos, that the carry flag for the Visual Studios is the CY. Okay, so for us, carry flag of CF is CY for Visual Studios. As you guys can see, nothing have changed here. So it pretty much means that there was no change of value from 0 to 1. Okay. The next one here, it says that we will jump to exit if ZF equals 1. ZF represents our 0 flag, and here in Visual Studios is the ZR, our 0 flag. So pretty much what this means is that once we keep shifting all these to the left, we're going to be adding I'm talking binary code, by the way. When we're moving to the left and binary, we're going to be adding zeros on the right side. So at the end, if your value is all 0 or just 0, this 0 flag is going to change to a 1. And that is when we exit. Okay? Alright, so, and here's an example I meant. See? We're adding zeros on the right side. Okay? And that's what's happening. Right? Okay. Let's see, next step. Now, jump to pair 1 if your CF equals 1. In our case, our CY. Okay? Yes, I know this is going to be this is a little crazy for you guys to be able to keep things straight between the standard, what you learn in the book or in the class, that the carry flag is CF, and Visual Studio uses CY. I guess they're just trying to be unique. I don't know, but anyway. Okay, so let's go click here. Nothing happened yet, and it says jump to start if CF equals 0. I'm gonna back up. Let me go ahead and move a little bit more up here. There we go. Okay, and it starts again, and then shift to the left. Nothing yet. Okay. Now remember, let me go back to the PDF. Remember that we're moving to the left, and so far we've been through the first 0, the second 0, and we're gonna get close to the first number 1, and then the second number 1. See. There we go. So when it got shift to the left, in other words, adding a 0 at the least significant bit, which means the right side, it moved a bit. In this case, the bit number 1 came out, and that's when the carry flag got changed to a 1. Okay. Now, see, okay, yes. So if it's 0 equals 1, so it's not 0 yet. How about this one? Jump to pair 1 if CF equals 1. The carry flag is 1, yes. That means it's going to jump to add 1, which it did. Now jump to add 1 if the SF equals 0. That's if there's a negative. Okay? Your sign flag. And I'll place the sign flag for the Visual Studios is PL right here. There's your sign flag. Okay? By the way, P stands for positive. Yeah, so that's why they have the P in there. Okay, let's see. So now add 1 if SF equals 1, if there's a negative. Okay. Okay. So now increment by 1. Here's our counter, the DX register. It's going to be our counter. It's going to be counting how many pairs we have in there. Okay. Next. So I got 1. Well, I'm sorry, I shouldn't say pair. I should say how many ones. Yes. Okay. And then I'm going back up here. And then repeating the whole process again. That's our second one. We add it here. Now we're gonna have two ones. And then go back up here. As you guys can see, what we're actually counting is just how many ones. Keep going. Actually, I should correct myself. It's actually counting the pairs themselves, increment by 1. Yes, it is counting the pairs. Let's see. Yes, it counted the pairs because of the changing of the the carry flags right here. Okay, so here we go. So let me go back to the PDF. Right now we are right here. That's where we are. That's where we are. We are at right now. At that bit. Go down. The carry flag is 1. Go to pair 1, which is true. Add 1. Jump to add 1 if the sign flag equals 1. Sign flag here is 1, which is a 1. Goes back up here. We're gonna do this counter. It's gonna add by 1. dx right now, where's dx? It's at 2. Okay. And then jump to start. Start it again. And then since your 0 flag right here is 1, we exit the program. Okay. Now, a value here on the dx. I want to be sure I'm saying this right. Yeah, the dx is the one that's giving us, is the counter for how many pairs do we have. Okay, so we have the 3 here, which is true. We do have 3 pairs. And if you go down here to the watch dx, the 3h is the same as 3 in decimal. Okay, and that's pretty much it for this program. Now let's go ahead and do application number 2, converting binary to grade code. Now be careful, because in this second application there's multiple files to open up. So let's go ahead and start with this one first. The one that looks like this. This is your first page or first file to introduce to the application to do the binary to grade code converter. Now, before doing any conversions concerning grade code, it's important to know what it is. Developed by physicist Frank Gray, the grade code was the answer to a physical problem. In the early days of modern computing, some binary values were expressed with physical electromechanical devices, such as relays and switches. It was soon found that these devices could have potential issues in quick computations, namely diagonal switching. So, the way this worked out, they made a truth table, and then using a K-map, they went ahead and came up with these results. Now this is where people get confused, because there's another file, this file, which pretty much is just explained to you with more details the conversion from binary. Let me zoom in here. Here's my view. Let me see. Okay. The sign of switching from binary to grade code and grade code to binary. Okay, so pretty much the steps are select 4-bit binary to grade code converter, do your truth tables, do the K-map, and simplify. So that's what they here. They were just showing you guys the truth tables, okay, and then the K-map, and all the way down the bottom. Let me score this a little more. Let me just make it like this for now. Oops, sorry. Yeah. There you go. Came up with this. And then it shows also converting from grade code to binary, the truth table, the K-map, and it came up with the gates here. Now, the reason of showing you guys the logic gates, or pretty much the results, all this with the logic gates, it is because the logic gates, and here goes the more shorter way, or smaller picture, is going to help us do the programming. Notice that they're using XOR gates, and that's what we're going to be using in our code. So here's the code. Don't get confused because the first part is in one page and the other part's on the second page. And here is where they're showing the use of the XOR. Okay? Alright, and then of course here's the gray code to binary converter program. And here is again the XOR. Okay? Oops, my mouse is. Alright. Okay, so we're gonna go ahead and, as you can see, there's a loop here, a subroutine. So let's go ahead and put this on Microsoft Visual Studios and see what happens. Okay. So let's go ahead and open up Visual Studio here, like so, and let's go ahead and create a project. I already have my template right here. If not, just do a search up here, x86, click next. This one I'm going to make it simple again like the others. Lab 9, program 2. Okay. Now, I will put program 2, binary 2, gray. Because there's also program 2, gray to binary. Okay? But it's up to you guys how you guys want to do it. Alright. Create. Click here, here. Alright, let's go ahead and type it in. Don't avoid any copy and paste because the syntax is not gonna be, the fonts are not compatible. Alright, so here's my code. I went ahead and changed this to 86. Put a breaker right here next to move bx comma binary. So let's go ahead and build this. Build the solution. Now we're going to do debug. Start debugging. Alright. So what we're going to do here first, or what's happening here first, we're going to be moving the value of what binary is to register bx. In this case, binary represents F, and has a decimal, or the value 65,535. So we're going to move it to bx. Now this example, by the way, this value, so we can reference back to the PDF here, is from, let me see, it's here. Give me a second. Please. Oh, it's on the other PDF. It's on this one. Yes, on this. Okay. And on this PDF, right here. Let me zoom in a bit. Oops, too much. There we go. So here's the example right here. Okay, so we're going to be converting that value and then from binary, and the gray code version of it is 6,000. Now, of course, we're gonna this the has a decimal value. Okay, so let's continue on. Now, be sure you have your flags on. If it's not, then go to right click it. Go to flags, oops, right click, flags, your watch here so we can see the value in decimal. If you don't have it, just go to debug windows and watch 1. Okay, there they are. I added the 4 main registers. Okay, now just be aware, and we're gonna, let's see how many. Okay, here and this website, which is pretty good. It's a converter. The FFFF this is the decimal value, like I mentioned before. But here's the binary value. What we are interested is the binary value of these numbers. Okay, so here's the binary. Now, when we convert to grade code, this becomes 8,000 and has a decimal. Convert here, which becomes this in decimal, and this as binary. Notice that the first bit, the first value is 1. Okay, and you will, if you go back to the PDF here, not this one, this one. Yeah, this one will be a little bit more. You will see it here. This was more noticeable. That from binary to gray code, this one is the same value. Okay, and also here, notice that the first bit right here on the left is the same as the in grade. Okay, all right. So let's continue on. So I'm going to have 8,000H. Okay, or this in decimal, or in this in binary. Let's minimize this. All right. So let's go ahead to our first step here. Okay, got moved there, BX. It moved whatever's from BX to AX. It actually made a copy. That's a way to make a copy. And the next one here, let me move it up a bit. It says shift right 1 bit, whatever is on register BX. So just remember, recall that shifting right is the same thing as dividing by 2. So we're gonna end up dividing by 2. Okay. Oh, sorry, I almost lost my registers there. Okay. That changing this value. Okay. And now here we're gonna do the XOR. Okay. Just like these gates, XOR gates, logic gates. Okay. All right. So we'll do that, and then we're gonna move this answer, or the value of AX, which, as you can see, now it's converted to register variable grade, or the variable grade, and that's it. It's done. Now if I stop this, take off my breaker, and just do a regular debugging, you will see the value right here. See? And that's it for lab number 9, application 2, from binary to grade code. Right. All right. Now let's go ahead and do the second program for the application number 2. This will be conversion from grade code to binary. As you guys can see, using the logic gates, we're gonna use the XOR again. All right, and also this value can be the same as this value, right? So let's go ahead and see. Yeah, let's go ahead and do the programming part. I already have my Visual Studios open. Let's go and click create a new project. A template right here. I'm gonna name this lab 9. Application. To be honest, I don't remember what I named the last one. Let me go back. Oh yeah, here goes. Program 2. Okay, so I was do create project. This one next. Lab. Oops. Lab 9. Program 2. And this will be from gray to binary. There we go. This will be unchecked. Create. Open here. Alright, so let's go ahead and start writing things down. Alright, here's our code. Notice that we're going to be using a subroutine, a loop right here. Let's go ahead and we'll put our breaker right here. Let's go ahead and change this to 86. And now this value here, which is also known as the 11110, all these, all this right here. This is the decimal value. Let's see. And here on the PDF, not this one, this one. Is this the? Yes, okay. Right here, let me zoom a little bit more. We're gonna convert this to this. Okay, so the answer is gonna be A, B, C, D. All right. So let's see what happens. So let's see. Let's go. I want to show you one more thing. Let's see. A, B, C, D. I'm doing this. Let me double check about this, right? A, B, C, D. Okay, yes. So there's the binary version. And the one they're giving us, which is this one. See if I can do a copy here so we can see the difference between one and the other. Okay, good. It's this one. Okay. All right. Let's go ahead and minimize this. Oops. Let me open this one. Okay. So let's go ahead and build. Actually, before I do build, let me save it. Always good to save it. Okay. Build solution. Just wait. Okay, looks good here now. And click here. All right. So the first step is going to say, it says here, let's see, start from here. Let gray be this value. Okay. Binary is going to be the nothing. Move gray to AX. Okay, move it here. All right. It did. Move AX to BX. It's going to move here. Okay. As you guys can see, even though we use the word move or the instruction move, it's actually copying if you have already from one register to the other. Okay. And then after that, we're going to do a shift, also known as a divide by 2, shift once to the right, or shift right. Okay. That AX is going to change value. Okay. And now we're going to do an XOR with BX and AX. Okay. And then we divide by 2 again, the AX, or shift it to the right once. And then we're going to jump. If the ZF flag equal to 0, you jump to loop. Oh, I'm sorry guys, I forgot to put my flags in here. Let me right click, flags, the watchers. Oh, haven't done that. Oh dear, okay. AX, EBX, ECX, EDX. Okay, let's try this again. Let's continue here. Sorry about that. Okay, so our flag Z, or in this case ZR, equals to 0. So if that's the case, it's going to have this go back to the loop, if I'm not mistaken. Yeah, there it goes. And it continues on. That's not. Now until my 0 flag turns 0, that's when I'll get out of the loop. Let's continue still doing the same thing over and over. Pretty much what it's doing is for each bit, it's converting each bit. Yes, it's a low number. There it goes. So that should go to the next one. Let me move this up a bit. It's gonna move from here, it's gonna go to here. There it goes, there it goes. So that's a new value now, a new conversion. Okay. Now you can, I noticed that in the previous lab, we moved our binary to register BX. Here, they move it to register AX. Can you have done it the other way around? Yes, we could have. Actually, I said, could we have done it the other way around? Yes, we could have done it the other way around. Instead of AX, do a BX. Yes, and then flip it. Since AX and BX registers are used for these types of conditions. Well, guys, this is it. When I took this class, this was my last lab. So thanks for watching my videos. Please don't forget to check the description for more information where you can follow me and how to support me. Also, I will be putting the time stamps on the description. Well, have a good day. Goodbye.